Most people think that what we do is the drawing and the putting the pencil to paper, but what we really do is we listen to our clients. So it's really about a conversation with our clients to bring about a school or a building that works best for their needs. Then put that pencil to paper to be able to design the product and the building that then will get built for them. Sustainability has really been part of our culture, our firm, our design. You're going to get it no matter what, because we know that it's better for the environment, it's better for our clients, so why wouldn't we make that decision at the beginning?
When I started 13 years ago, we were doing a lot of LEED projects, and as a sustainability coordinator, I was looking at a building through a bunch of different lenses. So both how our built environment kind of uses natural resources, both to build a building and then to operate it, but also the health and well-being of the occupants that are going to live, work, or learn in that building every day. There's such a huge part of CO2 emissions that come from building energy use, but also it's one of the areas where our buildings can actually show a return on some of the investment that the owner might make.
Moseley Architects, we have not only multiple sectors, which are the building types that we build, but we also have multiple disciplines within our firm. Our office is set up in a real studio environment. That open environment allows us to have that intentional and unintentional collaboration with our engineers, structural, mechanical, electrical, work within our sustainability groups. So it's not just architecture, it's a holistic approach that really strengthens our team, strengthens our designers, and then strengthens our projects. So what Moseley Architects looks for when we're hiring new graduates is that we're looking for someone not only that has strong computer skills, so working within a BIM model, but they don't have to be an expert in that, because we're not expecting somebody that hasn't worked in a firm to have that experience yet. It's really about their ability to collaborate, to communicate. Sometimes it's going back to the drawing board because something you put a lot of effort and time into might not be what the client's looking for. So being able to take that criticism and then turn that around into a product that they will be happy with.
I got a Bachelor of Science degree in Biology and Environmental Studies from UNC Chapel Hill. Right after that, I went into the Peace Corps with my wife in Paraguay, did agroforestry extension. So kind of a very environmental focus. Then when I came back, found a job at Moseley Architects as a sustainability coordinator, entry-level position. So I worked for an architectural firm with no architectural background whatsoever. But that actually helped me because where my background was a lot more broad and focused on impacts of the built environment on the actual environment, I was kind of able to see it through that lens. And so not necessarily as an architect or an engineer, interior designer, but kind of blending some of those different possibilities together and asking some questions that maybe we wouldn't normally think of in our own discipline. We have an in-house program called Moseley University where I was able to take a bunch of coursework very quickly that kind of oriented me to the architecture engineering profession. Then also studying for and passing a few certification exams. And then when I focused more on energy performance, I became a professional energy manager. Solar energy starts with the sun. It's basically a free resource that we just have to tap into. We have panels on a rooftop usually that will be oriented towards the sun, and then the sun during the daylit hours is just showering that rooftop with free energy. So photovoltaic panel basically takes light, the photo part of the sun's energy, and converts it to electricity or the voltaic. Once that current is produced, that's in DC or direct current form, that will be changed to alternating current by an inverter. Then it's suddenly in a form that most of our buildings can use. I mean, at that point, there's a few different places that the energy could take. It could either go directly to the building if the output is less than what the building needs at that point, or if there's a surplus and some of that electricity can actually be exported back to the electric grid through a bidirectional or net meter where it can go both directions. And if we're going to do a rooftop array, there's two main types that we're looking at. One is going to go on a flat roof or really a low slope membrane roof. And the benefit of that system is there's really no mechanical penetrations through the roof membrane other than where the conduit and wiring are going to go back down to the electrical room. The other big one that we'll look at is for a standing seam metal roof or kind of a sloped roof. The benefit of those is that they just attach directly to the metal roof panels with small specialty clips, and there's really no additional ballast and weight that we might have to consider, because that can drive up the cost a little bit of a low slope membrane roof situation. So this is your assignment. Your school wants to go green and has decided to install a solar energy array on a flat membrane roof. Your assignment is to figure out how many panels you can fit on that roof safely and how much energy they will produce over the course of a typical year. So how do we create the best layout? What we're trying to do when we design a solar energy system is to maximize the amount of energy that's going to come out of that system. And usually that means putting as many panels as we can realistically fit on a rooftop. Now, the only challenge there is that we do have some other things to work with and around on a rooftop. Very commonly we'll have rooftop HVAC mechanical units, say some plumbing penetrations, other things to work around. So that'll be something that you'll need to take into account. We also need to make sure that there's some clearance between the panels and the roof edges. We don't want to get closer than about 4 feet, even a little bit more is ideal, just to make sure that there's adequate service clearance, and if there are any issues with that roof edge, that can be easily maintained. So as you design your array, keep in mind that the maximum number of panels doesn't always mean the maximum energy output. Take into consideration different variables such as the inner row spacing, or the amount of space in between different rows of panels, the clearances from roof edges and any other potential sources of shading, and different things like tilt angle of the panels themselves and the typical winter solar angle and your location. Once you've decided on the optimal configuration of your array, you'll need to figure out what length of the mounting bracket is needed to support the tilt angle that you've decided on. Play around with different configurations, see which layout is the best, and we look forward to seeing what you come up with. And thank you for working to make your school greener.